Hey guys, my name is Daniel Rett. I'm the founder of GrowDoc. And what we're going to talk to you about today is our grow room build that we did. So the reason why we built our grow room is one, we want to grow, and two, we want to do testing. So we wanted to try to have the most accurate environment as we could, and this is how we built an automation system with automatic humidity, and then we put a dehumidifier as well, and we were controlling the temperature with AC Infinity fans. So today we're just going to walk through on how we built it, what's the automation behind it, and kind of how it all works and builds together to have an automated grow system that sends you notification if your VPD is off and if your cameras are off, and as well as you can see that online what's going on in your grow room. So why you would want to build a grow room, let's say you're growing and you want to have the best environment that you can, because the environment plays a big factor. Just to give you an example, low temperature to the root zone will lock out magnesium, high humidities and wrong VPD will lock out calcium. So it's very important that you have your environment dialed in to have the best growth possible and have the plant be able to uptake all the nutrients it needs. So here we're just going to talk about what the pros and cons are of a grow room. So just to give you an idea of the pros, one, you definitely got strength. You don't have to worry about pipes collapsing like a grow tent, and you can set your lights up. You've got strong solid wood that's going to hold it together. Second one is you can get a really good seal here in your grow room where you can mimic that perfect environment and everything is sealed up. And then the third one is absolutely you can completely make it dark in there so that you can prevent light leak, which can either turn plants hermaphrodite or stress plants and cause lower yields. So those are the three strong points of having a grow room. As for the weaknesses, is one, it's not movable. It's solid built in there. Cleaning wise, having mold, if you had those issues, it could become a bigger problem. You can't just throw it out. You can't just move it in a different area. And those are a factor as well. And obviously the cost comes into play, which makes a grow room just a bit more expensive than a grow tent. So here's what the Raspberry Pi's camera look like. So the wires coming through, and these are just little adapters, and as you can see here, I've 3D printed some holders where it gives the perfect angle where we can put them. So here we have 1, 2, and the third one over here. And then that's where we have our webcam over there. That's the live footage that we can see on the screen. So other than that, these are the screens. We printed some 3D clips to have our wires for a hydroponic system held, and we have our lights. We also have our fan here, the 6-inch fan that pulls out air, and then we have the 4-inch fan here, and as well as we have our humidifier right here that throws in the humidity, and then we have our fan over here that just spreads the humidity out and gives the plant some air. So equipment wise, right here we have the Raspberry Pi, and it's connected to a camera on the other side that you can see. So how it works here, we've got the PoE adapter, so it's a power over Ethernet. So as long as you have a switch with your router, which you can buy for very inexpensively, $50 or so, it'll power your Raspberry Pi. So right here we don't have to worry about any power. This is all controlled by the network, and this is, I believe it only $30 more than the Raspberry Pi, just to add on. So we've got 4 of those, or 3 of those, sorry, that are in our grow room that are controlling our cameras, and 1 of those is controlling the automation. As for electrical, we have put in some electrical outlets, and one you want to, if you can, you would like to have it per its own breaker per outlet. Just especially your grow lights, those are taking probably the highest amperage. Your inline fans are usually smaller in amperage, and that's kind of the calculation you want. You don't want to exceed the maximum allowed or recommended for your breakers. You don't want to trip them and then lose your light in your rooms during light in, or when light's supposed to be in. So here we have the automated is just a computer set up with a webcam that's inside here, just so we have the screen on. As you can see, We're in the grow room, it's automated. So here's our automated humidifier. So what we've got here is we've got a 5-gallon bucket with just a hose that then connects to this bucket over here. And this is all controlled by a Raspberry Pi over here, the same as you've already seen. And then we've got over here, which is our, it's a Raspberry Pi adapter that can connect, and just by in the Raspberry code putting a 1 or a 0, we can decide to turn on a switch or on or off. And that's how we determine. We've got a sensor inside the room, and with that sensor we can then decide to turn on the humidifier or turn it off. So we've got the AC Infinity fan here and an ultrasonic mister inside the bucket with a float that then controls the exact amount of water needed to make humidity. So this makes humidity, and then with the fan, the AC Infinity fan pushes it in the room. So once the humidity gets, well, for us it's in vegetation state, so once it gets to about 52, we throw some humidity until 56, 57, 58, and then it kind of turns off and tries to regulate. And then that's the humidity you can set up accordingly, and you can also set that up according to your VPD. So you could have it exactly set to where you need it according to the temperature that's in the grow room. And then we also have our AC Infinity fans here that are in our grow room. So the wall has been built just in the regular way that they frame walls. Every 48 inches we put a stud in between, and then we just put a top plate over here that just attaches both walls. And then there's the same style on the wall on this side, and then we just made some adjustment to fit a door. Another thing that's very important about the door is we've got some cushioning here, which is, it just expands, as you can see. So this cushioning is all around the door as we put, which then gives it a perfect seal. See, so as you see, it's all around the door, and then once we push it, it's gonna cushion in, and that's where our locks come into play. So here, when we lock it correctly, we can pull it tightly down. 2 locks, which makes an almost, we're missing some, but makes an almost perfect seal if we have enough. It is a perfect seal over here, we just don't have any over here. So that's how you keep it as, let's say, secure or tight as possible, sealed as possible, to keep your temperature and environment right.